Traditionally, machine learning education focus heavily on model training, but in production, inference is where organizations spend most of their operational budget, right? So every user request trigger inference, every token generated consume compute resources, and every millisecond of the latency affects user experience. As ML engineer, we need to think beyond model accuracy, and we need to understand deployment, latency optimization, GPU utilization, cost efficiency, monitoring, and reliability. Modern AI products succeed not only because of the great models, but because of the great inference system. So I told about, I generally keep telling that inference decide whole your AI product will pass or fail, right? Because so many directions are there, so many dimensions are there, and if you are not build a good inference infrastructure or good inference systems, even you have a good models, and if your suppose your latency is not good, security systems around not good, hallucination, truthfulness, or the way you model tracking, right, and the cost part, these are you're not within that acceptable things, then maybe your overall things are not working out, or overall whole product will fail it. Now, let's go to the part that why inference is hard, right? Why inference is hard, right? Now you must have got idea that inference is a really complicated engineering problems, and because of that, there are many things to optimize, or many dimensions these things are going on, and you need to optimize it. For example, inference is hard because of the latency. Inference at a glance, inference sounds simple, but load a model, send a prompt, generate response, but it really much more complicated, right? There are, you need to balance all these directions. Like we want low latency, we want high throughput, we want high availability, low cost, we want efficient GPU utilization. So the challenge is that improving one metric often hurts another. So it's like these all are going different direction. So how to build a system there where all can optimize it, or all direction. So this becomes a sort of optimization problem also, right? So challenge is the improving one matrix, right, but without hurting to another, or combining together to more of optimize. So for example, larger batches improve throughout but increase latency if you increase the batch size, right, but they increase the latency use. So throughput will increase, but latency will, latency will increase, right? This is why inference is involved with distributed system problem. So inference is not only ML problem; it's like more of compute, memory, hybrid, all this together. So and then ML itself, like how you can optimize your models in inference time. So there is ML part, there is a system engineering part, there is distributed system part, and then whole ecosystems around that where they are combining together. So therefore, it's a difficult, actually I would say it's hard, and you need a right set of a skill set for to build a highly scalable inference systems.